We want to find the dihedral angle between two planes. So I've got a piece of cardboard here, and I've just got two triangular surfaces. The important piece is the line of intersection between the two planes. So the edge that joins the two planes together. We have that line of intersection. All the work that we're going to do to find the dihedral angle comes from working with the line of intersection. What I need to do first of all, step one, is we always take an auxiliary elevation to find the true length of the line of intersection. So if I come along and take an auxiliary elevation, just for example something like that, now I've found the true length of the line of intersection. I'm looking in at 90 degrees to it. From that view we project an auxiliary plan, and the auxiliary plan is basically me getting this and rotating it back up there so that I see an edge view of the line of intersection. So here's my line of intersection. When I get it in the right view, it looks like a point, and at the same time when that looks like a point, you'll see that both planes look like edges, and it's in this position that I can measure the dihedral angle. So I can see the true angle between the two planes. That's what the dihedral angle is all about. So what's the real angle between them? It's only in this position I can see it. In this first question, we have to find the dihedral angle between surfaces A and B, and the setup that we have here in plan view is similar to what you're looking at there. So I've got a triangular surface A, it'll represent it here roughly, and I have a triangular surface B, it'll represent it here roughly. First of all, I'd always highlight the line of intersection. So the line that joins A and B, I'll just put it in red for this example. There is my line of intersection. It's important to put the line of intersection in the elevation as well. So the line of intersection between those two is here. That is the line I'll be dealing with. I'll number it all up so we can start doing the drawing. Alright, so I've highlighted my line of intersection and I've given labels to all the numbers. So my points that I've got, 1 and 2 is line of intersection. Here's 1 and 2 in elevation. I've got point 3 and point 4. A triangular surface is the easiest one to find the dihedral angle because you've only got 3 points on each surface to deal with. I need to find the true length of line 1, 2. To draw that, it'll mean I need to look in here at 90 degrees. So I look in at 90 degrees. In there. So that is the first view that I set up. It's a standard auxiliary elevation. So to do that, I need to look in here at 90 degrees. I'm going to project out at 90 degrees to 1, 2. So I'm going to come out, project out 1 and 2, and 3 and 4. So my 1, 2 and my 3 line in this question are fairly straightforward because they all line up. So in other words, they're all going to be in the same position. As always, set up my XY line, just come out a little bit from the drawing. I'll set up my XY line. It'll become my X1, Y1, and that's going to be important, so make sure you label it. I'm drawing an auxiliary elevation. So my measurements are going to come from elevation. My measurements always come from the previous XY line. The previous XY line in this case is this XY line. So again, I'm working from the previous XY line, taking my measurements from elevation. That is why we take our measurements like that. So the height of 1, here's position 1. Height of 2 is 0, it's on the XY line. And the height of 3 and 4, 3 when I bring it up is on the XY line, so the height of 3 is 0, and the height of 4 is 0. So what that's showing me, the true length of my line of intersection, which is here, and I'll highlight that in red. I'll just constantly highlight the line of intersection in red in these questions. And my surface 1, 2, 3 is here, and the surface 1, 2, 4 is in between, behind it. So this is showing me surface A and B, one in front of the other. But that doesn't matter. Now I need to come along and project out an auxiliary plan. To project my auxiliary plan, I need to look along the line of intersection. So exactly as you've seen it here, I took this and looked along the line of intersection. So my eye is looking down along the line. What that means when I come to a drawing is to look along the line, I'm projecting out in this direction. So my eye has moved here, and now I'm looking down along that line to see it as a point. So I'm projecting down in this direction down here. Again, same thing, I need my XY line, so I'll set up at 90 degrees to that. Again, this is an x2, y2. It's the second view. I'm drawing an auxiliary plan now, and my same rules apply. I'm going to measure from plan. I'm going to take my measurements from here, and I'm going to measure from the previous xy line. I'm on x2, y2 at the minute. The previous xy line is x1, y1. So when I measure out my distance for number 1, it's x1, y1 to point 1 in plan. Take it out and strike it off. The distance for point 2 is going to be the same distance, and it's coming along the same line. And that's how we end up with a point view. 1, 2 are in the same position. I can come along with the same points 3 and 4. So I project out point 3 and 4 parallel. I project out my points 3 and 4. The distance to 3, x1, y1 line to point 3 is a very short distance. I get it here. So point 3 is, and point 4 to the x1, y1 line. And again, I'm following out my point 4, and I get it out here. And that gives me point 4. So I've got a point view of 1, 2. Surface 1, 2, 3, which is surface B, is here. Surface 1, 2, 4, which is surface A, is here. My line of intersection, which is my red line, here's my red line, is here. So it's a point view of the red line. And my dihedral angle, I can measure it with a protractor or just highlight it. Here is my dihedral angle. I have my dihedral angle labelled. I'll just come along and measure with my protractor. So measure around 0 all the way around. It's 115 degrees. So the true angle between planes A and B is 115 degrees. Second question, so again, find the dihedral angle between surfaces A and B. Now, this question is a little bit trickier in that I've got 4 points on surface A and 4 points on surface B. I still have a line of intersection, and that's the first thing I'll always highlight. So I'll highlight my line of intersection in red. Line of intersection up in the elevation is here. Now, I can save myself a little bit of time. I'm going to cut the two surfaces, the two planes, into triangles. So what I'm going to do is I'm going to take point 1, 2, this is point 3, and this is point 4. And I'm going to bring those up to elevation. So I've got my points in elevation and plan there. What I'm going to do now is I'm going to chop a little piece off A. And I'm going to chop a little piece off surface B. So what I'm doing is I'm cutting away this piece of the surface, and I'm cutting away this piece of the surface, and I'm just dealing with 1, 2, 4 for surface B and 1, 2, 3 for surface A. It's the same thing. All I've done is got the two flat surfaces, chopped a piece off them. I can use the same method now. I need to draw an auxiliary elevation to find true length. Auxiliary elevation needs to come in at 90 degrees to my line of intersection. Here's my line of intersection. So I'm going to be projecting out here at 90 degrees. I've got my 90 degree angle. I'll project out all my points. So 1, 2, 3 and 4, all out at 90 degrees to that line of intersection, my red line. XY line, again parallel to the line of intersection or at 90 degrees, doesn't really matter. I get my x1, y1. It's an auxiliary elevation I'm drawing. I'm taking my heights from elevation. So the height for point 1 is here. I follow out point 1. Height for point 2, again off the XY line. I project out point 2. Height for 3 is the same. Project out point 3. And the height of 4 is the same. Height of point 4. That doesn't matter, the method is still the same. Height of point 4. Now I've got my line of intersection, 1, 2. And once again, I'll highlight it in red so I know which line I'm dealing with always. I've got the surface 1, 2, 3 is here. And I've got the surface 1, 2, 4 is here. So I've got my two different surfaces here. I'm going to darken in surface 1, 2, 3 just so it makes a little more sense, just to separate it out from 1, 2, 4. So half of 1, 2, 4 is lost in behind 1, 2, 3. That gives me the true length of my line. That's what we're looking for. Now I can project off looking along that line. So I need to project out here looking along the line. Once again, line of intersection. I'm going to project out looking along it, and I'm going to set up my x2, y2 line. Auxiliary plan I'm drawing, so I measure from plan. While I'm at it, I'll project out all of the points just together just to save a little bit of time. So I've got 1 and 2 projected out. Here's point 3 projected out, point 4 projected out. Distance for 1, 2 to the xy line. There's my distance. When I come along, 1, 2 is out here. Distance to 4. Here's the distance to 4. And again, follow out. Gives me point 4. Last one, distance from my x1, y1 line to 3. Again, it's in plan. And I follow out 3, and I find it. And I get my surface 1, 2, 4 and surface 1, 2, 3 with my point view of the line, and my dihedral angle is here. Now, this comes in handy because you can work back the way as well. I could have found the edge view of surface 1, 2, 4, so we'd say surface B. If I had been told this angle between surface A and B is 130 degrees, if I only had this surface, I could come along, measure an angle out here of 130 degrees, draw in the surface 1, 2, 3, and you can use it to kind of work back. We'll be doing a couple of them questions later. But again, that is just our dihedral angle. Done.